Okay, ladies, this is our cycle 1 week 17 experiment called Rock Bridge. It's number 138 in the Van Cleves book. The only materials that you're going to need for this are some books and some chairs, and a ruler. Now, the ruler we have already in the kids' zip-up supply bags. But then the books and chairs are obviously already in class. The books, my thoughts on this were, rather than you guys bringing a bunch of books to class that day, you might be able to use some of the hymnals from the church and maybe borrow them that morning, from after like opening assembly. Just grab some from there and then bring them back to your classroom. But rather than everybody use all the hymnals, it might be better if we share the materials and just rotate the books from class to class. Maybe 3 classes can do science while the other 3 do art, and then we swap, and then a mom can deliver the books to the next classroom. So we'll work out those details at our meeting. But the purpose is to demonstrate how natural bridges stand. And so in the science sheets that I'll be giving you, it gives some really great questions about where they might observe rock bridges. Some people may have traveled in places where they might have seen them, just like these. And it's kind of cool to consider how they've used rock bridges as a guide to help them learn in architecture how you can get a natural bridge to stand. And so great discussion questions there, but it's fairly simple and it doesn't take a whole lot of time to do. But you are going to be teaching them about the center of gravity, which is explained not only here, but also explained in the Van Cleves book. So all objects behave as if their weight is located in one spot called the center of gravity. The book bridge is supported because the center of gravity of each side of the bridge is over a chair. In nature, natural rock bridges are formed by weathering and erosional processes. So it would be good to discuss weathering and erosion, which have really good explanations also in on the science sheets. So what I've done is I have 2 chairs, and forgive the mess, but I have 2 chairs that are about 1 foot apart, and I measured that, and you can do that with your students. Grab 2 chairs, take a ruler, and show them that they're about 1 foot apart. And then you're going to take 1 book at a time, similar to what you see here in the Van Cleves book, and you're going to slowly slide them over and over. So you have 1 book on this side. Make sure it's on the same side here, or the same distance on the chair. Mine isn't perfect. I probably should push this forward just a little. But just to show them, kind of like stairs, going up to the top and then back down. I think this took me 9 books total, but you can certainly do more. And with the older classes, you could give them other opportunities to show this same type of skill as far as center of gravity goes. I've seen people make these bridges similar to it, just really teaching the center of gravity using Pringles. They took a can of Pringles and they tried to slowly slide them apart until it actually can create a circle. And I will post a picture of that in the comments. So that's optional if you wanted to add that as an extension. But I believe, let me double check. I think we're doing one other experiment, week 17, or maybe this is the only one actually. Let me double check. I think this might be the only one we're doing that week. So yeah, if that's the only experiment we're doing on week 17, you're going to want to have some kind of extension for this because it's not going to take very long. I would suggest, asking maybe moms to bring a bunch of books to class that day, or you can bring some of your own from home and practice using different size books, different surfaces. You can do, instead of 2 chairs, you could do 2 tabletops in the classroom. So I will try to look for more extensions to discuss at our tutor meeting, but this one's fairly simple.